In this video, I will discuss factors that affect reaction rate, and then we will go over some examples like what you might see in an exam. To understand reaction rate, we must understand how reactions occur. From the particle theory of matter, particles are in constant random motion, as seen here. What is needed for a reaction to occur? We need a collision. So these particles that are in random motion, we need a collision to occur. And we need these particles, when they collide, they have energy. We need the energy in which they collide to surpass the activation energy, as I drew out in this graph here of an endothermic reaction. We also need the particles to collide in correct orientation. Okay, so what factors allow for these three elements to be met? What increases a reaction? What decreases a reaction? The first factor that affects reaction rate is temperature. An increase in temperature increases the reaction rate. If you have two substances in a beaker and you heat the beaker, reactions will occur more readily. Why? Because if we go back to the example where we have particles in a beaker, they are moving at constant random motion. We know this. And they're moving at a certain kinetic energy. When you increase the temperature, you're increasing the kinetic energy at which these particles move. So an increase of temperature increases the kinetic energy. And if there's an increase in kinetic energy, these particles are moving faster, and there's a higher chance they'll collide. The opposite is true if you decrease the temperature, like if you put this beaker in the freezer or in the fridge. It's going to decrease the reaction rate. Okay, concentration. If you have an increased concentration, this will increase the reaction rate. Why? Well, let's go back to a beaker. If we have, say, 2 particles of each for an example, there's a low chance that these 2 particles will bump into each other. There's just too much empty space. But if we add way more particles to this beaker, there's just way more particles moving in constant random motion, and there's a higher chance one of them will collide. The opposite is true if there is a low concentration. That will decrease the reaction rate. Surface area. An increase in surface area means we will have an increase in reaction rate. The reaction will happen faster. And if we have a decrease in surface area, there will be a decrease in reaction rate. So, for example, if we put, say, a sugar cube in water, and you have water molecules coming after the sugar cube, they're only able to come after these few faces, and maybe some water gets underneath. They're really only able to attack the outside surfaces of this sugar cube. But if, say, I put a sugar packet in here, I'm going to make the sugar orange. So if I sprinkle in sugar into the water, we're going to have all these loose, separated crystals of sugar. Now, when the water comes at it, each little clump of sugar will have water coming at it from all directions, meaning we have an increased surface area here. It's like we took this block and broke it up into all these pieces, making it easier for the water molecules to get to each and every individual particle. So that means there'll just be more collisions. Mixing, agitating, stirring. So this will, if you're mixing or agitating or stirring the beaker, this means there will be an increase in reaction rate. So stirring equals increased reaction rate. Why? Because you're just making it easier for collisions to occur. Electrical energy. If you add electrical energy, you will break bonds, and which will increase reaction rate. Therefore, increasing reaction rate. Adding electrical energy just provides you with enough energy to be able to break bonds through a process of electrolysis. Okay, now let's talk about catalysts versus inhibitors. How do they work? So, a catalyst speeds up a reaction. Speeds reaction. Whereas an inhibitor slows or completely stops a reaction. Okay? So, how does the catalyst speed up a reaction? Well, it lowers the activation energy needed. So let's just go back up to this picture I drew here. So this is a pretty large activation energy, but if I add a catalyst, say in blue, the catalyst will shorten the path to reaction, which will decrease the activation energy. We see that this distance between the reactant and product has decreased. That's how catalysts lower the activation energy. So particles can collide and they don't have to have such a high energy when they collide. An inhibitor works in many different ways. It can increase the activation energy required for a reaction. It can block active sites, alter enzyme shape, or even remove reactants. But the important things to know for inhibitors at this level is that it slows or stops a reaction and it is not used up. So it's not like a reactant that's used up to create products. And catalysts as well are not used up. Okay, now that we've gone over the factors that affect reaction rate, let's go over some examples. First example, what will react faster? Well, this is a question of surface area. So which has increased surface area? This block or this block that has a bunch of rivets and dents in it? Well, it's B. Because if we make this a little bit bigger, we can actually see that all these little dents and rivets are increasing the surface area. There's an increase of surface area here. Whereas in this image, you can only get the 4 sides of the cube, meaning less collisions. So B will react faster. 2. Reactant A was left in the fridge overnight. Does this allow for a fast reaction or a slow reaction? Well, if we left something in the fridge, this is a question of temperature. And we know if we increase the temperature, there's a fast reaction. But if we decrease the temperature, like in this example, we get a slower reaction. Number 3, electrolysis of water provides enough energy to break bonds or form bonds. From before, we know that electrolysis breaks bonds. An example of this is the electrolysis of water. Okay, Number 4, a solid is left undissolved in reactant A. Which of the following options below will increase the reaction rate? Heating the beaker, this is increase in temperature, so yes, this will increase the reaction rate. Stir the mixture, that will also increase the reaction rate. Add more reactant A. This is about increasing concentration, so this will increase the reaction rate. How does a catalyst speed up a reaction? Well, it decreases the activation energy needed. Does an inhibitor increase or decrease the reaction rate? An inhibitor decreases the reaction rate. I hope this video cleared up the factors that affect reaction rate.